Hello! In this video I'm going to go over significant figure rounding rules, and this should answer that common question of how many digits do I round to? Well, the answer will be significant figure rounding rules. There's 5 little rules, although I'm going to summarize them in less than 5 rules. But the first one is all digits 1 through 9 inclusive are significant. So any digit 1 through 9. Basically the only thing that's not significant is 0. However, zeros are significant in certain situations, and that's what the rest of the rules are about. When are those zeros significant? Number 2, zeros between significant figures are always significant. So here's an example. 5007, those 2 zeros are between 2 significant figures, the 5 and the 7, which makes those zeros also significant. I call it the sandwich rule. Let me just write a little word, sandwich. Then we got 3. Trailing zeros in a number are significant only if the number contains a decimal point. Example, 100.0 has 4 significant figures. Really all these other rules could be summarized with this statement. I find this a little bit easier. So you have to say yes to both of these. If the 0 is after the decimal, like if you say yes, it's after decimal, alright. And if 0 is after a sig fig, which is short for a significant figure. So if you say yes to both of these statements, then that 0 is indeed significant. But if you cannot say yes to both, then it is not significant. Alright, so this will make more sense when we do some example problems. It says determine the number of significant figures in the following numbers. We got 0.02. That 2 is definitely significant, but now this 0, we got to look at our statement above. If the 0 is after the decimal, and if the 0 is after a sig fig, then it would be significant. This 0, is it after a decimal? Yeah, it is. But is it after anything significant? A number 1 through 9? The answer is no. So that 0 is not significant. So we're only going to have one significant figure, that 2. 0.020. Let's see. That 2 is definitely significant. This 0, we're going to have the same deal as in the first question. Is it after a decimal? Yes. But is it after anything significant? No. So that is not significant. How about this 0? Is it after a decimal? Yes. Is it after a sig fig? Yes. So that is definitely significant. So that number has 2 significant figures. Doing 501. We got 5, 0, 1. That 0 is in between 2 sig figs. Therefore, sandwich rule says it's significant. That gives us 3 significant figures. Then we got 500.0. Those 3, 5, 0, and 1, those definitely are significant because that 0 is following the sandwich rule. But now this 0, we've got, it's after a decimal, yes. It's after a sig fig, yes. So therefore, that 0 is also significant. So we're going to have 1, 2, 3, 4. And the reason that 0 is significant is it does have an absolute purpose. Its purpose is to show that you rounded to the nearest tenth, and you measured, yes, it was 0. It wasn't 1, it wasn't 0.2, it was 0. So 501.0 is definitely different than 501. 501.0 is more precise, more accurate, more focused. Next we got number 5. 5,000. That 5 is significant, but these 3 zeros, they're after a sig fig, but they're not after a decimal, so they're just placeholders. They're not significant. We just have one significant figure there. However, if you got 5,000 point, that point, it's kind of a weird exception. We didn't talk about this rule yet. These zeros are after a sig fig, but they're not after a decimal. However, there's a decimal point right there that shows rounding, which means it's not just 5,000, it's 5,000 point. So those 3 zeros are significant. It's a 4. So yeah, a little confusing. It's one of those things where once it clicks, it's not too bad, but before it clicks, it might be a little tricky. So if you see a decimal, that usually means that those zeros in front of it are going to be significant. Alright, we got 6,051.00. That 0 is significant because of the sandwich rule. these two zeros are after a decimal and after two sig figs, so therefore they also are significant. So that's 1, 2, 3, 4, and 5, and 6. 0.0005, this 5 is significant, but then these three zeros are after a decimal, but they're not after any significant number, so they are just placeholders, not significant. That only has one significant figure. Next, we've got 0.1020. That 0 is between two sig figs, so it is significant. This 0 is after a sig fig and after a decimal, so that's also significant. 1, 2, 3, 4, 4 sig figs. 10,001. These two zeros are between two sig figs, so sandwich rule says they're both significant. 1, 2, 3, 4, 5. There happens to be 3 zeros between those two sig figs, so all 5 numbers are significant. All right. Since we're at it, why not have some more fun and do these problems together? It says determine the location of the last sig fig. All right. So looking at this guy, it's after a sig fig but not after a decimal. That 0 is not significant. Looks like that 4. And I'm just going to circle the number that has the last sig fig. All right, this 0. Well, first of all, that 3 is significant. So looking at these guys, are they after a sig fig? Yes. Are they after a decimal? Yes. So they are significant, so the last significant figure is at 0. Well, this one's pretty easy, number 3. They're all significant, so that's your last significant digit. Tricky one, number 4. We got 2.000 times 10 to the second. Anytime you have times 10 to the second, it's just saying, it's telling you where the decimal is, or how many zeros you're going to add to that. So they are not sig figs, not including significant figures. So that leaves just this whole number. We've got 3 zeros after decimal and after a sig fig, so they are significant. And I'm going to circle that last one that's significant. Same with these guys. They're after a sig fig and after a decimal. So those zeros both are significant. Moving on to this, 90,100. These zeros are after a sig fig but not after a decimal. So this 1 is the last sig fig. 4.7, again, times 10 to the negative 8. Not significant. These two numbers, 4 and 7, are, so I'm going to circle that, or box that 7. The last significant figure. 10,000, no, that's not 10,000, that's 10,800,000. But there's a little decimal point. Technically these zeros would not be significant, but there's a decimal point saying, no, yeah they are. So that 0 is significant, that's the last one. Again, 3.01 times 10 to the 21st, times 10 to the 21st, not significant. The, well, 1, that's a significant figure, so I'm just going to circle that. This 0, is it significant? It's after a sig fig, it's after a decimal, so yes, it is significant. Alright, and that is significant figures. Basically, practice, practice, practice makes perfect. And that is significant figures.